Good morning, children. I'm Sanis here. I hope you all are fine. Hope you all have completed the exams and hope you all have done well. Okay. Now you all know that we are doing our 14th lesson, electric current and its effect. So first we saw the symbols of the electric components used. We saw how a symbol is used for a battery, then how it is used for a cell, then how how wires are connected, how a bulb is there. So we all saw these small things. Now we also studied about the heating effect of the electric current. In electrical appliances, there is a coil of wire. This is called the element. So when current is flowing through this element, what happens? It becomes hot. It gives out heat. So this is the heating effect of electric current. We can see the element red in color because of the when electricity is passed, it becomes hot or heat is given out from that. So it is visible because the element will be red hot. It is red in color. So we know that these coils are examples used in the room heaters, then all the electrical appliances, iron boxes, all those things, we know that kettles, in all those things, these elements are there, and we have seen how the heat is produced when electricity is passed through it. Now we are going to see the next part of the lesson, that is the magnetic effect of electric current. So, how a magnet can be made using the electric current. Okay, we will see how the magnetic effect of electric current is produced. Now, I am going to explain the activity 14.5. Now, take a matchbox tray. This is a matchbox tray. That is where we put the matchsticks. Take that out. You have to place a magnetic small compass needle in that. Then take a wire and you have to wound around the match tray, as you have seen like this. You have to wound it. Wound means you have to cover it like this. Then the two ends of this wire has to be connected to the bulb and switch and the electric cell. So this is the circuit diagram of that. So you have taken a match box tray. Inside that you have small compass and the wires, you have to wound the wires on it and then connect it to the switch and the electric cell. Now, when the switch is in on position, the electricity starts flowing. So, what happens when the electricity is flowing? You can see this magnetic needle deflecting. That means it will show deflection, means it starts moving. Now, one more nature is about the magnet. That is, when the magnetic needle or a magnet is freely hung. So, example, if this is a magnet, this will have north pole and the south pole. The magnet will have north pole and south pole. And tie it in a string, and if you hang it like this, it will always show north-south direction. That's how the magnetic needle is. It will always show north-south direction. Now, when the electric current is flowing, this starts deflecting or it starts moving. It will show different directions now. So, that is the magnetic effect of electric current. So, we say that when the current passes through the wire, the needle shows deflection and it behaves like a magnet. So this is called the magnetic effect of electric current. So what is it? When electric current passes through a wire, it behaves like a magnet, and this is the magnetic effect of electric current. Now, this was first uh, uh, said or first noticed by a scientist named Hans Christian Ørsted. So, this is the name of the person who first noticed this magnetic deflection or the magnetic effect of the electric current. Okay, next is we will see how magnets are produced. That is, electric current can be used to make magnets. So I'll be explaining the activity 14.6. Now, you have to take a iron nail. This is a iron nail, and you have to wound the wire around it. That is, you have to coil it with the electric wire like this. Then this has to be connected to a switch, then to a cell. Then you have to put few pieces of pins over here. Okay. Now we will see what happens. Now when the switch is in on position, we all know that the current will flow. So when the current flows through this, until sometimes you can see all these pins sticking to this. That is because this nail will behaves like a magnet. So all the pins will stick here. Now when this switch is off position, what happens? All the nails will fall down here. The current stops flowing and the no more this acts as a magnet, so this will fall down. So we know that when it is connected, when the electricity is flowing through this, all the pins will be sticking here. That is because this nail, when electricity is flowing, it acts as a magnet, so it will pull all the nails, it will attract all the nails here, all the pins over here. So when the current electricity is stopped flowing, there is no magnetism, the nail will lose its magnetism and all the pins will fall back. So now such coils are called electromagnets, or these coils are called electromagnets. Now these electromagnets, they are used in so many places. For example, they are used in cranes. We all know cranes are used to lift heavy loads, right? So at the tip of this cranes, they will have some magnets like this. So it is easy for them to lift heavy loads, and in a place where they dump waste, they use these cranes so that all the iron articles will be sticking to them. It will get stuck to the magnets, so that it is easy for them to take off the waste or iron materials from the waste. Then it is also used by doctors. These electromagnets are also used in toys also. So these are the places where the electromagnets are used. Now let's see how an electric belt works. Before that, we will see the circuit diagram of that. Okay, you have uh, a coil wound with a wire. So these are acting as the electromagnets over here. So this coil of wire is the electromagnets, and close to that you have a iron strip. The iron strip will have a contact screw near that. So that is connected to the switch and the cell. This iron strip also has got a hammer, and the hammer is close to a gong. This is the gong. So this is the circuit diagram of the electric bell. So I told you this is the electromagnets. This is the iron piece with wire wound on them. This is connected to a iron strip. This iron strip is having a screw and this is connected to cell and switches. This iron strip also has got a hammer. It is close to the gong. This is the gong of the bell. When this hammer comes and strikes on this only, you get the sound. So now this is the circuit. Now we will see what happens. Okay, when this iron strip is close to this contact screw and the electricity is passed. When the electricity is passed, this coil, this electromagnet will behave as a magnet. So this iron strip is pulled closer. So what will happen when this iron strip is pulled closer? This hammer will come and strike on this gong to produce the sound. At that time, what happens over here? I told you this is the contact screw. When the iron strip is pulled closer, here the circuit will break. The iron strip is pulled closer to the coil, so the hammer will strike on the gong so that you hear the sound. At that time, what happens over here? The iron strip is now far away from the contact screw. So now no more the electricity is passing through that. So what happens? The current flowing through this will stop. The coil is no longer electromagnet. So what happens is this will go back to its original position. This will go back to the original position. When this goes back to the original position, this iron strip is also going back to this original position and it touches the screw again. So when this touches the screw again, the electricity is passed. The electromagnets behave as the electromagnet. The iron strip is pulled closer. So this hammer will come and strike on this to produce the sound. Again, when the iron strip is close to the magnet, here the circuit will break. The contact screw, the iron strip will become far away from the contact screw. So now what happens? Now this will strike on this to produce the sound. Now what happens? Here there is a gap. So now there is no more electricity passing through that. So this comes back to now no longer this is an electromagnet. So what happens? This will go close to the switch and this will go back to the original position. So that is how you hear the sound of the electric bell. So I told you there is a coil of wire that is called the electromagnets. These are connected to you have a iron strip. This iron strip is attached to a hammer like this. This iron strip has got a contact screws also. So when the contact screw is touching this wire, what happens? The electricity flows. This electromagnets will behave as magnet. So this iron strip is pulled closer so that when this is pulled, this hammer comes and strikes on the gong. This is called the gong. When it hits on that, you hear the sound. So when it is touching, when this hammer is touching the gong, this is closed. So the contact screw and this iron strip is far away now. So after when you hear this sound, what happens? Immediately when this is far away, now no longer the current passes. So this will go back to the original position. The hammer also will go back to the original position. Now the sound is stopped. Now what happens? Again when the screw touches this iron strip, electricity is passed. This will be pulling this closer. So this will come and hit on this. Understood? So there will be a gap produced here. So this will stop the current flowing and no more you will hear the sound. Then it will go back to the original position. So this is how the electric bell works. So I hope you understood this, children. The working of electric bell. So that's all about this lesson. We are completing this lesson, electric current and its effect. Go through the lesson properly and write all the fill in the blanks at the back of the text. Hope you all will do so. Have a nice day. Thank you.